Hi, Dipti Vachani. I'm thrilled to be here today to talk to you about the journey to autonomous. A journey I believe we all can share, and each of us will have an important role to play. So you might be expecting that a talk on a journey to autonomous would be all about autonomous cars. I'm going to talk to you about much more than cars. This is a big opportunity far beyond that. We see innovation in areas like industrial automation, transforming how we manufacture, smart cities impacting how we live, and transportation changing how we get around. When we look at the autonomous opportunity, we start with a focus on the workloads. It's about distributed machine learning, the right processing, at the right place, at the right time. Essentially, a network of networks. We can apply autonomous technologies to local IoT decision-making. In industrial, the combination of human and robots will make it even more efficient. And of course, the journey includes more autonomy in vehicles. But as you can see here, the opportunity is far greater. The journey to autonomous is about the connection between the hardware community and the software community. Let's talk about software first. The application of autonomous decision-making in low-power MCUs we call endpoint AI. As IoT developers, we face basic choices. What cloud? What device do we use? What OS middleware do I use? We want to navigate these choices quickly so we can focus on our innovation, our workloads, our products. Embed technology is contributing to the next generation of cloud tooling. This results in an agile, modern, and robust tool chain for low-power devices that can enable your development board from prototype through to production, while including a support for a wide range of MCU and development boards. We are collaborating to bring this support to other leading IoT RTOS platforms, as well as supporting connectivity to multiple clouds, optimizing your development choice, any workload, any device, any OS, and any cloud. On that note, I'd like now to take a moment to talk about some really exciting news to enable AI and IoT developers with our friends at Microsoft. Pay attention because this is really, really cool, and it truly propels us toward a real out-of-box experience. I'd like to introduce Mo Tanabian, Vice President and GM, Azure Edge Devices at Microsoft, to give you some more details.
Thanks, Dipti, and a big virtual hello to everyone. At Microsoft, we're in the business of making digital transformation easy, fast, and cost-effective for our customers. Arm and Microsoft have been close partners for many years. And the next step in our partnership is deploying an integrated Azure toolchain targeted at ARM-based silicon to enable streamlined edge AI development experience for our developers. This will enable our developers to target a broad range of ARM-based silicon in AI-enabled devices, things like intelligent and computer vision-enabled cameras, connected vehicles, AI gateways, and intelligent appliances, to just name a few. This will cut the development time in half for building such edge AI-based solutions in Azure and based on ARM silicon. And it will also enable our OEMs to build devices that are simple to set up, secure, and always delivering differentiated value to our customers. With this in mind, we will be sharing something important around Microsoft Edge AI very soon. So join us and learn how all of us are working together to make the future come faster. Thank you. And back to you, Dipti.
Thanks, Mo. Our companies working together like this is great news for us developers. I look forward to seeing what we can do together in the future. Now I'd like to move beyond the endpoint and talk more broadly about processing across the edge. The low energy and cost constraints of endpoint AI can limit the amount of processing. Processing can be done in the cloud, but the volume of data, privacy concerns, increased latency, this just isn't possible every time. The solution is to process the data throughout the edge, where you have performance and power, more performance and power than the endpoint, but are closer to the data than the cloud. For this to succeed, we need to offer the same out-of-box experience that cloud-native software developers have become accustomed to, while running on extremely diverse range of compute devices in the edge. This is the vision of Project Cassini, to lay the foundation for cloud-native developers' experience across a diverse and secure edge ecosystem. Project Cassini is an industry-wide initiative bringing together a set of programs around 3 main focus points: standards, security, and ecosystem. For standards, the newly announced ARM System Ready program is driving more consistent baseline OS support through a system architecture certification program. This builds upon the success the Server Ready program has already had at the data center. For security, we are extending Platform Security Architecture Certification program to the edge by collaborating with Cloud Native Compute Foundation on a program called PARSIC. This focuses raising the bar for security system design across the entire edge. Finally, ecosystem. This is where Project Cassini comes to life, bringing the vibrant cloud-native software ecosystem to the edge compute nodes. ARM is working with a number of our partners to deliver key reference implementations in this space. Success for Cassini will ultimately depend on you, the developers, bringing your enthusiasm and innovation to this vision. Cassini is foundational across the edge. Now let me talk specifically about the work we're doing upon building on the capabilities of Project Cassini to address autonomous workloads across the edge. In autonomous systems in general, we see a drive towards software-defined functionality, a huge increase in complexity of what software aims to achieve. Paired with an increase in computing power, increased abstraction of the underlying hardware, the drive towards software-defined functionality means an emphasis on enabling cloud-native technologies like containers and workload orchestration. Virtualization, real-time, and safety are already key technology enablers in industrial and automotive. But autonomy now also brings additional emphasis to hardware-accelerated machine learning. Project Cassini initiatives will enable security and elements like virtualization and containers by enabling a more portable OS support. To address autonomy, we add capabilities for functional safety, real-time, machine learning, and mixed criticality. We are building these capabilities of Cassini to enable an autonomous software fully leveraging the potential of the ARM ecosystem and accelerating your development. We're creating a portable open source reference stack, freely available, actively maintained, and contributed to by our robust ARM ecosystem. It will be designed first and foremost for autonomy. This is an important starting point for our journey to autonomy. I encourage you to check out a TED Talk from Matt Spencer if you're interested in learning more. The opportunity and journey to autonomy is not complete without hardware. The combination is truly where magic happens and where products are made. Cortex M55 and Ethos U55, launched this year, bring great leaps in ML processing within the power-constrained environment of an IoT endpoint. Cortex R82 is our new R-class processor, which marries the real-time capabilities needed for many demanding and highly customized applications with the additional ability to run a rich operating system and ML workloads. And of course, our AE CPUs, GPUs, and ISPs, bringing high-performance processing with features that can enable safety required for autonomous applications like industrial and automotive. We are truly at the beginning stages of this extraordinary journey. There are some amazing examples that I want to share with you, and one of my favorites. When we put software and hardware technologies together, we can make amazing products. Products that truly change lives. The Neosensory Buzz is a device that enables people who can't hear to experience sound. Imagine that. Using ML software running on Cortex M processor, it captures sound and with endpoint AI, autonomously translates them into a rich vibrational pattern that the person can experience. This can be truly life-changing and shows that autonomous everywhere is just more than robots. But of course, we love our robots, myself included. Misty is an open source robotic platform that is designed to trigger the imagination of robotics developers everywhere. Misty has a range of features to enable developers to create their own applications. For example, she has a high-resolution camera and a structured light sensor to map her environment and navigate autonomously within it. How cool is that? Developers can take Misty and create their own autonomous application, She could be a security guard, a teacher. The possibilities are endless. Misty can really bring the power of autonomous workloads to a range of applications in our everyday lives. Here's another example, Bob Assist. Bob enables easy predictive maintenance. Drop Bob onto the equipment to be monitored. He learns from the vibrational data it captures, and he builds a model based on that data. Bob then starts to analyze, looking for anomalies. He can do inference every 5 minutes for 4 years on one battery. Pretty cool. And that brings us into the industrial application. Autonomous decision-making can make a real difference in manufacturing. ARM-based technology is already deployed extensively in the factory and warehouses. We're focusing our efforts on this segment to enable autonomous future of the industrial sector, smart manufacturing. Factory production lines will become reconfigurable, enabling flexibility, adding value, and saving cost. Smart manufacturing enables efficient use of resources and the ability to meet changing demands in production, customization requirements, and logistical needs. And fewer but reconfigurable factories and warehouses will be better for our environment sustainability. This could be transformational for our environment and our economy. Now I'm going to talk about autonomous vehicles. And yes, we all love our cars, but we aren't going to leap straight to cars. By enhancing the autonomous capabilities of ADAS technology today and applying it to restricted operational domains where routes, speeds, location, and environmental conditions can be bounded, we can start this journey to deploying autonomous vehicles now. These autonomous vehicles can help to address the growing demand for last-mile delivery, enable fixed-route shuttles, and also transform road freight and ride-hailing services. These are real applications of autonomy that we can start to see commercialized soon. And the experience and learning from these constrained autonomous deployments will prove invaluable to understanding how we might tackle the future challenge of unbounded operational domains and the ultimate of fully autonomous vehicles. Thank you for your time today. I hope you're as excited as I am about our journey to autonomy. Autonomy will change everything, transform industries and our everyday lives, with applications we can't even imagine yet. Enabling autonomy requires dedicated software technologies, supported by the right hardware. Developers are key, and we are focused on providing tools and experiences that just work. ARM is committed to do this journey alongside all the great developers in the room. Thank you very much.
And we have decided that it's time to move into a new commitment from ARM around this world that goes all the way from the cloud all the way out to the edge. And today we're announcing for the first time ARM Neoverse.
Tonight I'm excited to announce the EC2 A1 instance, which is powered by the AWS Graviton processor.
And that's why this partnership with Docker is so impressive, because now all of a sudden we have these millions of developers that can leverage all those devices.
The cultivating of the ecosystem for ARM has been really fantastic. We had a good friend over at Oak Ridge start working on it right away.
It's a true NFV platform. It's got embedded ARM accelerators, all of those running ESX as well, which means they can have applications downloaded to them.
We look forward to working with this community in the coming years to continue to innovate and make sure ARM is a first-class architecture for all we do in the CNCF.
So I'm excited to announce today the launch of a new set of instances, the M6G, the R6G, and the C6G instances for EC2, which is a new generation of ARM-based instances powered by AWS Graviton 2.
At nearly 100 times faster than its predecessor, the Fugaku will usher in a new era of technological capabilities.
As you've heard at DevSummit, applications like industrial IoT and autonomous driving will fundamentally change the way we live and work. And a common denominator of these new applications is that they will ride on an intelligent, software-defined, and highly sophisticated digital infrastructure. It will be the invisible fabric that makes everything else just work. ARM is on a journey to bring together an ecosystem for building tomorrow's digital infrastructure. Over the past decade, we've been partnering with leading software developers, chip designers, OEMs, and cloud providers to understand their strategies and collaborate on technologies like 5G and cloud-native development. Reinventing the digital infrastructure is one of the biggest opportunities in technology today. It's also one of the biggest challenges. But don't just take it from me. Hear what our partners have to say.
When you are optimizing systems and when you have a large number of systems, let's say, given that you have 100,000 servers, a 1% increase in performance would mean a saving of 1,000 servers. Now, the other one is the footprint in the data center. As you can pack more compute services in the data center using lower footprint, you have a huge saving in real estate and energy costs. There is a huge event we call the Global Shopping Festival. It is also called the Singles Day because we probably process more merchandise than the 4 biggest shopping days in America. Now, for that day, what is really important is there are lots of Java applications running. So optimizing Java application is crucial for us. We have a very strong collaboration with ARM engineers to help us to see where the performance issues are and how can we do better on ARM. So this is a very good relationship for us. And through the relationship, we have developed tool sets and analytics methods to optimize the software systems on the ARM architecture.
Task 是一个可以帮助你快速构建应用的微服务平台。Task 在腾讯使用了10年之久，现在它已经是 Linux 基金会的开源项目。我们和 ARM 的第一个项目是实时路况，我们能够为用户提供比现在 GPS 信号高10倍的准确率的一个位置，所以我们需要在云上以及边缘节点上面不断提高计算的性能。我们还和开发者在 ARM 的服务器上使用 AR/VR 技术，为用户提供虚拟教室。我们很高兴加入 ARM 的生态，并且在软件和硬件领域构建更丰富的基础架构。
As software grew bigger and bigger, as we built more and more complex apps, and as more and more traffic started going online, something we have, by the way, seen a lot more of happening during the COVID pandemic as well, you need that many more infrastructure resources. With cloud native, you can build technology in a way that it is composable pieces that can be spun up and down, and you can make changes to specific pieces without having to rebuild a monolithic application. There's always the race to manage more with less in technology and computing, and that will continue. We need more container density, more cluster density to be able to do that. For that, technologies like ARM are critical.
We think there are 3 essential pillars for building the next generation infrastructure. First, we need silicon that is targeted at specific performance goals and use cases. Second, we need to unify an ecosystem around standards. Third, we must work relentlessly to make software and product development as frictionless as possible. Let's take a look at targeted performance. From a high level, digital infrastructure revolves around a race between work and watts. Whether you're running quants or binge-watching Cobra Kai, consumers and businesses have an insatiable thirst for digital services. As a result, the work performed by data centers has been growing exponentially. Data center workloads grew over 8 times in the last decade, while internet traffic grew by 12x. Energy consumption, however, has generally stayed flat due to optimization techniques like server consolidation and virtualization. For cloud economics, flat has been vital. It has allowed cloud providers and developers to serve more customers without incurring exponential increases in cost. Applications like video conferencing and smart cities has also made data centers a key player in the drive for sustainability. So what could that mean for the coming decade? Let's reset the clock to this year. Workloads and internet traffic will still be doubling every 2 to 3 years, or might even accelerate past that. Power consumption, however, could grow by 2 or 3 times, or even more, without new ideas or technologies. A surge in power consumption like this would mean higher operating costs, higher equipment budgets, increased emissions, and potentially slowing demand. The ripple effects would be felt across the ecosystem. It could even have a bigger impact on the edge, where space, power, and cost will be an absolute premium. Now here's the good news. We think this is a future we can avoid. Neoverse is our platform for servers, networking, and other infrastructure equipment for solving the performance power dilemma. Neoverse is designed to deliver maximum performance while minimizing power, space, and other resources. Let me give you an example. These represent 2 42U hypothetical server racks. Each consumes 12.5 kilowatts. The one on the left contains servers built around traditional multi-threaded processors. The one on the right consists of servers built around an 80-core processor from our partner Ampere Computing, based on the Neoverse N1 technology. Because of the power performance that Ampere and Neoverse deliver, more threads can safely operate within the same physical space and power budgets. The result? The rack with traditional processor contains 2,240 threads, while the Ampere solution packs in 3,200, a 44% increase in capacity. Compute performance per rack more than doubles, and performance per core increases by 48%. To put it another way, think of each thread as a container, each container as a customer. Ampere's solution lets you serve up to 960 more customers and provide them better performance with the same amount of power and the same amount of real estate. In other words, more work per watt. Last month, we showed more details on V1, codenamed Zeus, the first in a line of cloud processor IP for premium performance and the most complex workloads. V1 provides a 50% performance uplift over Neoverse N1, our current leading Neoverse IP. N2 is also coming. N2 is focused on scalability, density, and performance per watt. It provides a 40% uplift over N1 within the same footprint for better operational results over a wide range of applications. Expect uplifts in performance of over 30% or more on a regular cadence with Neoverse. ARM's IP roadmap also provides a screaming fast fabric supporting the latest interfaces and memory technology, while allowing our partners to take advantage of the most advanced manufacturing nodes. The results achieved by our silicon partners are igniting demand in the cloud. Premier cloud providers like Tencent, Baidu, Microsoft, Packet, and Oracle are adopting ARM-based systems to accelerate performance and lower costs for their customers. At AWS, customers such as Netflix, LexisNexis, and Redbox are enjoying increases in price performance of 30 to 40%. Every morning, I love to check my Twitter feed to hear from enlightened users delighted with the transition to ARM-based instances. Whether you analyze it in terms of speed, or cost, or sustainability, the impact is the same. Our partners are finding Neoverse delivers a fundamental step change in cloud performance. I encourage you to test it out yourself. Spin up an ARM-based cloud instance and see how your workloads run on ARM. Once you have core technology, the next step is establishing standards to provide a powerful platform for the ecosystem to thrive. Earlier this week, you heard about System Ready for building a wider variety of solutions. System Ready establishes a framework for the common components of software stack, like the hypervisor and the operating system, so that hardware and software from different vendors work seamlessly. We are rolling out a few flavors of System Ready that align with specific software requirements, use cases, and market needs. Typically, building for System Ready doesn't add to silicon area, code size, or firmware development costs. Instead, it becomes a flywheel for your innovation and success. System Ready is also part of Project Cassini, an initiative with our partners to deliver a cloud-native experience at the edge. Project Cassini gives developers, hardware manufacturers, and ultimately their customers a common framework for developing and deploying at the edge. By participating in Project Cassini, developers will be able to write applications once and have them work on systems from a wide range of manufacturers. And as you can see from the logos, Cassini and ARM System Ready are gaining significant traction. Semiconductor companies to software developers are participating. So are industrial conglomerates and startups just coming out of incubation. A number of them are speaking during the breakout sessions this week. If you focus on one issue this week, I'd like you to make it Project Cassini. The edge isn't just about moving the data center closer to the user to reduce bandwidth. It's about building a broad-based, high-performance platform for real-time applications and services. Once you have core technology and standards in place, removing the friction for developers comes next. We've been engaging with leading companies at every level of the stack, from networking and operating systems to languages and libraries, to ensure that developing on ARM is as easy as possible. We're now a first-class citizen on many commercial and open source software solutions. Support for ARM is often ready to go the first day of a release. And the ecosystem continues to expand.
We at VMware have been working closely with ARM to explore how to bring virtualization to ARM's power and cost-efficient compute ecosystem. We took a major step in this journey last week at VMworld when we announced Project Monterey, which uses our ESXi on ARM implementation to enable compute, networking, and storage acceleration on ARM-based SmartNICs. Today we're excited to announce the next step, the launch of our ESXi on ARM Fling. A VMware Fling is an open technical preview that customers and partners can try out in different environments and use cases. This will help us explore bringing vSphere to a wider range of devices, from data center to the edge, and reaffirms our commitment to the ARM ecosystem. Learn more at our technical session. Thank you.
One area we are particularly excited about is continuous integration and continuous delivery. Cicd is a linchpin for developing cloud-native applications on ARM. Last year, we announced our initial collaboration with partners like Travis CI, Drone.io, GitLab, and Jenkins. Since then, GitHub, Azure Pipelines, AWS Code Pipelines have announced support for ARM. Packet also began offering CI as a service for Travis and Drone.io. We have some exciting announcements this week too. AWS has now announced that it's offering Travis CI as a service to give developers more options when it comes to getting testing and quality control. Meanwhile, we're also announcing that Circle CI will provide native support for ARM, with ARM becoming a first-class computing option in Circle CI. The effort across every layer of the ecosystem means developers can deliver incredible results across a wide range of workloads. Let me share with you some of the highlights. NGINX is one of the most popular web application servers, powering over 35% of active websites. On average, NGINX achieved a 54% performance gain on M6G instances across multiple workloads. And by the way, those NGINX cycles were priced 20% less. Ceph is a leader in software-defined storage. With ARM, Ceph saw 26% better performance, 40% lower CapEx, and consumed 51% less power than the previous target cluster. You're seeing it across other benchmarks too. Quite honestly, Java was not a strong suit for the early generations of ARM-based servers. Now, on spec JVM 2008, Neoverse provides a 43% uplift. Or take a look at intense workloads like EDA simulation. Neoverse beats traditional architectures by 54%. Or Memcached, 43% better performance. Some of the CIOs and CEOs I get to meet act like a kid at Christmas when discussing the value proposition that ARM in the cloud is delivering. None of this would be possible without your creativity and support. Together, we're shaping the future of computing. Drew Henry said it best last year at ARM TechCon. Thank you, thank you, thank you. You helped make this happen. I've covered a lot of ground today, and hopefully got you to start thinking about the future of infrastructure. Please reach out to ourselves or our partners, and to learn more, go to developer.arm.com/infrastructure.
Hello, and welcome to today's session. My name's Ian Smythe, and I lead the marketing for the client business in ARM. I'd like to introduce my colleagues, Richard Grithenswaite, our Chief Architect, Mark Hambleton, who leads our software engineering, and Jem Davis, who leads our ML group. We're here today to discuss how software and hardware interact in ARM and how they contribute to the evolution of the ARM architecture. ARM's traditionally seen as a hardware business, but really, there's a huge role for software to play here, and that's what we'd like to explore today. Let's start with a really simple question. So Richard, what's the process of creating the ARM architecture?
Well, contrary to what some of my colleagues sometimes think, we don't just go up an ivory tower and think deep thoughts and hand it down. The generation of the architecture is inherently a very collaborative process, because the purpose of CPU architecture is to define the hardware upon which software will run to solve real problems. And so we end up working with all of the major operating system vendors across the world in order to make sure that the problems that they are seeing will be solved by our hardware. And indeed, I first met Mark many, many years ago, I think some 15 years ago, when he was working for a major operating system company, and we were collaborating on what needs to be in the ARM architecture to solve the problems they were seeing at that time.
Yeah, and that was right at the beginning of the smartphone revolution. The world was mostly single core. Right. And so one of the first problems we had to explore was how you go to a multi-core environment for operating systems that weren't designed that way. So it's all very well saying we'll glue two things together and it'll all work, but what are the implications on software? How do the software ecosystems then adopt that piece of hardware?
And Mark, what are the big problems that ARM is focused on solving for developers?
So that's a very difficult question to answer. I would immediately go towards security, right? We've seen lots of stories that hit the headlines over the last few years, but actually 70% of the security vulnerabilities that show up are actually the same thing, and it's an age-old problem of memory protection, right? Overshooting the end of arrays or using a bit of memory once it's been freed, right? It's an age-old problem that we've been leaking vulnerabilities into the software ecosystem. And so in ARM, we're actually looking at tools that we can provide to the developer to help them find and fix these things before they're leaked, or find them in running software, running software that's already out in the market. And that leads us to memory tagging extensions.
Right.
Richard, do you want to pick up?
Absolutely. So actually, there's quite an interesting history here, because for many years, I think the hardware community felt these are software bugs. The software guys have just got to get this right. It's their problem almost. But the reality is the problem is too hard. We've got 50 years of memory safety issues, and they keep on coming. As you said, 70% of them have been around. That has been the run rate for many, many years. This problem is not going to go away simply by saying to the software people, you need to work harder. We therefore need to have facilities within the hardware that makes it easier to find these issues. And so with the memory tagging extensions, which we developed in conjunction with Google and working very closely with the people who have developed Address Sanitizer, it's really about providing tools to allow you to find the vulnerabilities that exist in the core, the places where buffers do get overflowed, where there is use after free, finding those before they can be exploited, and providing a tool that can be actually running all the time in existing hardware at a minimal performance overhead, so that these can be found in real-world situations, not just in the lab.
Yeah, because no matter how hard you try, you're not going to find every bug in the lab, go through every sequence of code before the code is deployed. The size of software that's deployed these days is just going up and up and up, right? So having that ability for end users, without realizing it, testing and finding problems which can then be fixed and pushed back to their device is extremely important.
And one of the tremendous things that we've got today is the fact that there are literally billions of devices running similar pieces of code. You know, everyone looks at very much the same sort of applications. And so what happens is you end up with a crowdsourcing of the security debugging, so that everyone, by having their situation being looked at to find these vulnerabilities, means that that information comes back and is able to improve the software and pushed out in future releases. It's a tremendously exciting time compared with where we were maybe 20 or 30 years ago, where software was in a single box on your computer and was unable to sort of work with anything else. This connectedness provides tremendous opportunities, and the memory tagging is a huge amount of what we can gain out of that feeds into that connectedness.
Jem, another big area is ML. Surely everything changes now, right?
Well, some would say, and certainly I would go along with it, that it's a once-in-a-generation inflection in computing, possibly a once-in-a-lifetime inflection. And so you might think it's all completely different. But in many ways, it's more of the same in terms of the way in which ARM and its architectures and its processors evolve. Because, as Richard is saying, we provide architectures and processors to execute software. And we try to get it to do it well, and it's the sort of software that our partners want to run. Well, actually, machine learning is just that, only sort of scaled up a bit.
And the ML space is particularly interesting. It's not obvious exactly what attributes of the hardware that you need. You might have the right compute capability in the CPU. You might need a dedicated accelerator. We also haven't specifically solved the problem of how ML plugs into the wide variety of use cases that software is generating for it. So it's a very evolving space. We're working with lots of different communities, lots of different ecosystems to figure out exactly how ARM technology fits in to their need, to service their needs.
We are able to take a pretty neutral viewpoint on this compared to some of the other people who will tell you, oh, the answer's a widget, you know, and we say, well, it might be, or actually you might just want to use one of our CPUs. You might want to run this code on one of our GPUs. You might need a dedicated neural network processor. For different people in different cases, there will be different answers. And ARM's great strength is that we are able to respond in that way. And the trust in which we're held by our partners means that we can give those answers and generally be believed.
And I think it is important. You're absolutely right. There's been a sort of, in people's minds, they said, machine learning requires a different processor. And the people who are pushing their own accelerators would obviously say that. My answer for this has always been no, because some workloads, frankly, by the time you've got to an accelerator and got going on it, you could have done the thing on the CPU if it went a little bit faster on the CPU. All working together, and a big part of this is how you provide a software layer, which we've got in the form of ARM-NN, to make it more seamless as to where this runs.
And that speaks to the diversity of the ARM partnership. the same code needs to be able to run in many different contexts on many different flavors of hardware. That's why you need to invest in the software frameworks to be able to make the decision about where a particular task is done less visible to the user so that it's able to use the right attributes of whatever hardware platform it ends up landing on.
ARM is, you talked about it, ARM is at the center of this huge compute ecosystem. And we've talked about the technologies that we're trying to apply here. How do you set the technical direction with the partnerships?
And we want the solution to be applicable for the microarchitectures across all of those different points. So it requires hardware understanding, it requires understanding of the software, and an awful lot of it requires partnership and working with the different companies and the different people. And this is how it develops. And for incremental improvements in the architecture, these become, very much developed in collaboration and cooperation with our partners.
Yeah, some of the most valuable features for the ARM architecture are the ones that we didn't put in, right? Software really, really benefits from the stability of the architecture and making sensible, reasoned decisions about what you do. Right? The more we fragment and expand and not use things that we've put in, the more complicated we make it to land software onto those platforms. So from a software engineer's perspective, the stability of the architecture is one of its most valuable assets.
Well, it can actually run the same code from 20 years ago to today, and that longevity is very important. I've often joked that a feature in the architecture is for life, not just for Christmas. It's really quite important that a feature is put in there is something that we can commit to, because the last thing you want to do is put it in there and 2 years later go, oh my goodness, that was a mistake, I wish we hadn't done that. And one of the first principles you discover is people will use features in ways that you don't expect.
Exactly. And one of today's trends is the evolving movement of the cloud, edge, and endpoint, right? Where you're seeing workloads where you could deploy them at any of those three nodes in the network.
It's particularly prevalent in machine learning. We've got partners who are making, believe it or not, pressure transducers so sensitive and so cheap that they can put them into training shoes, running shoes, and it will measure your gait because of the changes in pressure as you lift your feet. Generates a lot of data, very little power. Obviously, we want to analyze that data using machine learning algorithms to say, oh, he's not doing his feet right or whatever. But it's actually almost the same code as is running on supercomputers in data centers. We need to reflect the performance scaling across there, but also understand what are the nuggets, what are the bits that are the same that we need to produce architectures and processors for.
Thank you. I mean, you all talked about the incremental changes and the linking to the future and the importance of consistency. How then do you go about making a fundamental change to the architecture?
Well, the first thing to recognize with fundamental changes is they happen more rarely than you expect. Jem talked about ML being a once in a generation or a once in a lifetime change. Everyone thinks the next big thing is just around the corner, but in reality they happen relatively rarely. But when they do happen, they don't happen by magic. And there is a real challenge in getting these things started, because the natural form of the world is to evolve forward rather than to take big steps. And we've been thinking very hard about how to do some of that big step stuff, because particularly in the area of security, we're aware that the basic programming model really goes back to really the 1960s and the 1970s. It hasn't changed. And maybe we should be exploring a bigger a new type of solution and a bigger solution to the problem. And the trouble is, what you really need is hardware and software, as we've talked about. But the hardware doesn't get justified building it until you've got some software. And the software to justify it doesn't get written until you've got the hardware. So there's a vicious circle, a chicken and egg problem I often talk about that we get stuck in. And we've got an opportunity at the moment. We're doing some work under the banner of Digital Security by Design with UKRI to produce an example, a reference system as a prototype for a new type of security solution based on some work we've done with the University of Cambridge. to bring in these things called capabilities as a way of encapsulating with an address how you're allowed to make use of it. And this could be a really powerful building block for a future more secure world. But the problem is we can't just impose that on the world because it's a big step and we don't know whether it's solving real problems. So we want the software world to go and work with this and play with this. So as a result of this research program, we're actually producing these Morello boards, which we will be working with universities and companies to explore the applicability of this technology to then feed into, is this an architecture we want to bring into the future? This is a tremendously exciting opportunity, and some of our very biggest partners are involved in it, as well as getting some funding out of the UK government to make this real.
Yeah, and the interesting thing about Morello is although we're building some hardware, everybody likes that because it's a real thing, it's physical. The most important thing, though, is to engage the software communities. It's those software communities that are going to take the new proposed architecture, work with it, and figure out if it solves some of the key problems that they've got, right? Does it actually add value or does it just add overhead?
And we take the feedback from that software work to actually refine the hardware. One of the exciting things about Morello is we've actually deliberately made it have more features than I would ever dream of putting into a real architecture, so that people can try doing this way or that way, and we can genuinely ask those questions.
We talked about the architecture, and you also talked about the scalability of it. I mean, we're famously sensor to server as an architecture. How is it possible to have an architecture that really scales across all of those areas? And what are its advantages?
One of the things it's useful to think about is what joins these devices. You know, what is this endpoint thing and how does it connect to this cloud thing? And you say, well, it's the data. We've got a world now of absolutely millions and billions and going on 1 trillion connected devices which are generating data. And it is simply not feasible. It's just the laws of physics will not allow all of that data to be sent to a data center, processed and sent back. And so we have to be processing these data at the appropriate point, whether it is at the network edge, whether it is at the endpoint device. And that processing increasingly involving machine learning, as you'd expect me to say. But really it is that data that defines that scaling. And so we are all the time thinking about where is the right place to do this computing. And as Mark points out, that tends to move. You know, there's not a right answer often. And so often these workloads will move. They will scale both upwards and downwards. You know, what used to be code that would be run on a supercomputer actually ends up, particularly in my field, in machine learning, ends up being run on the endpoint devices. And so having an architecture that at its heart and processors that at their heart reflect that reality, that we scale from things that, you know, literally run off a coin cell battery for 10 years up to, you know, kilowatt devices, is very important to us.
And I think a key part of that is, again, the focus that we put on in ARM about thinking about what is the architecture rather than what are the implementations. Well, we're able to do this because we've got this standard architecture that we have focused on. Again, will it work on the small devices? Will it work on the big devices? We might put in some extensions to aid the bigger systems that we're talking about, but we always think about, and what would a small implementation of that look like so that you get that compatibility? Because compatibility is the key to everything. The moment you lose it, you fragment.
Thank you, gentlemen. One final question, really, to each of you in turn, if I may. Right? Over the next 5 to 10 years, what is it that you are most excited about? Richard.
I think for me, I mean, I've been at ARM a long time, and the fact that we have actually really started to break out of our homeland of, you know, the mobile phone, the smartphone, and are really, you know, we're in the world's largest supercomputer. We're being taken very seriously in servers. We've got very compelling solutions in the server and the cloud space. Basically says that this vision of being, you know, the architecture for the digital world, basically the computing platform that everything can run on. I think there's a tremendous opportunity for all of us in the ARM partnership as that, and it's a tremendously exciting and privileged place to be.
Mark.
For me, it's the evolution of the edge. Right? I've stood up at Linaro events and I've talked about edge computing and how I see it as being really important to get it right from a security and safety perspective. And the migration of workloads between cloud and edge device and how we then hook in the endpoints. That becoming real, I think, is the most exciting thing I can see over the next 5 years.
Well, it's machine learning and AI. You'd expect me to say it. To have the opportunity to surf this wave is just the most amazing opportunity. Inevitably, AI will somewhat under-deliver first to people's expectations because expectations are too high, and the robot butler and the self-driving jet car are probably a few years off yet. But the other things that it's going to enable, the other things that it will power, from the mundane to the miraculous. Some things are just going to work better. You know, a smoke alarm that doesn't go off when I'm frying a piece of fish because it knows I'm frying a piece of fish and it's not really a house fire. Yeah, that's probably not going to win any awards, but it's going to be nice to have. So there's going to be lots of mundane things that are just going to make life a lot better. And the miraculous, well, the thing about being part of the ARM partnership and not being responsible for everything, but enabling other people to have stupendous ideas on top of our technology means you get a free ride to some of those really quite spectacular things, which we probably can't imagine today.
Thanks, gentlemen. That was really fascinating. I hope you all enjoyed it too. Thank you for joining us today.